All right, welcome to part 3 of chapter 13, ANOVA video lecture. And so in this video lecture, we're going to cover step 4, how to make a decision when we have a hand calculation, as well as steps 3 and steps 4 for SPSS and ANOVA, specifically how we obtain our F-test through SPSS and how we look at the output and make our decision for SPSS. So here's Tom the Toolman helping us out with our tools. So here we see we have the same 4 tools, almost exactly the same from what we saw when we learned about independent and dependent samples t-tests. So the first tool is our actual test statistic. In this case, we have our F statistic of 12.218. What about our significance level? What's our significance level usually set at? Alpha is equal to 0.05. And what about our degrees of freedom? Well, in this case, we have 2 of them, right? We have degrees of freedom between and degrees of freedom within. So we have both. And so given all of that, we need to look at our critical value so we can actually make our decision. So let's take a look at our critical value table, which is provided to you in titanium. So here's another table. Oh, not that table. This table. So let's take a look. This is the critical values of the F distribution for P is equal to 0.05. So this is when we have our alpha level set at 0.05, and it's going to give us our F critical values. And note that we're using a different critical F values table from that in the textbook. Make sure you use this table that's provided to you in titanium and not the one in the back of your book. If you use the one in the back of your book, you will get different critical values, which means you can get different answers. And you do not want to get different answers, which could mean it could be the wrong answer, by simply using the wrong table. So let's take a look at what this table tells us. First part, we have DF1. Well, DF1 is going to be your degrees of freedom between your groups. This is your numerator. Whereas DF2 is your degrees of freedom within groups, your denominator. So given the data that we have for our scenario, our degrees of freedom between groups is equal to 3, which means we're going to look where? Down this column. And if our degrees of freedom within groups is equal to 28, which row are we going to look at? Are we going to look at the row for 25 or the row for 30? Do you recall what I said last week in terms of how we look at our critical values tables? Well, since we have degrees of freedom within groups, that means we've passed the threshold of 25 degrees of freedom, but we have not passed the threshold of 30 degrees of freedom. So given that, we're going to select the row for 25. So we look at these thresholds in terms of have we passed these numbers, and if we have, that's the row we use. If we have not, we haven't reached that threshold. So given that, we now have our critical value, which is equal to 2.99. So one last note. Notice that we have more for both degrees of freedom between and within our groups. And so the rules for this table are, for your degrees of freedom within, your more is going to be 150 or more. Whereas the degrees of freedom between, your more is going to be if it's 30 or more. Make sure you know these numbers. All right, so some things before we actually make our decision. The thing about your F-test, your F statistic will always be positive. And the reason for this is because your mean sum of squares is simply squared values. So you're never going to have a negative number in any of your calculations. So because you have no negative number, you're really never going to have, it is not possible to ever have a negative F-test. If you've calculated an F-test that is negative, you've done the calculation wrong. Go back and redo the calculation because your f-test will always be positive. And like previous tests, your f-test also has critical values, just like we saw. And these f critical values depends upon the number of groups that you have. So the more groups that you have, the smaller your critical value. The more people you have, the larger your sample size, the smaller the critical value as well. So the more groups and the more people within your groups, you're going to have a smaller critical value, which means whenever we compare our f-test to our critical value, it'll be easier for us to reject the null. But if our alpha is smaller, instead of having our alpha at the standard 0.05, if we reduce that to 0.01 and we're more conservative, well then we're going to have a larger critical value because that means it's going to be harder for us to reject the null and find significant differences. So take a look at this. This is our distribution curve for our f-test. Notice that it is not a normal distribution, which means we cannot predict the probability of a certain score. So now that we have our critical value of 2.99, we have all the tools that we need in order for us to actually make our decision. So here is our rule for ANOVA. If your critical value is greater than your f-test, you fail to reject the null hypothesis and state that there are no differences. However, if your critical value is smaller than your f-test and your f-test is bigger than your critical value, then you reject the null and state that there are significant differences between your groups. So looking at our data, we have our critical value of 2.99, and we have an f-test that we hand calculated that came out to be 12.218. Well, given that, given our rule, we see that our f-test is greater than our critical value, so we're going to reject the null and state that yes, there are significant differences between our groups. So going back to our research question, do different superhero costumes result in more severe injuries? Well, yeah. There are significant differences between superhero costumes on the severity of injuries. However, do we know which superhero results in more or less severe injuries? No, we don't. At least we don't know yet. The thing is, the ANOVA f-test cannot tell us which groups actually differ. Our ANOVA f-test is what's called an omnibus test, which means it tests only for overall differences. It does not tell us which groups specifically differ from each other. It just gives us overall differences. What we need to do is we need to look at Tukey's honestly significant difference test. Tukey's HSD test, which is a type of post hoc analysis. Post hoc meaning after the fact. And so we only look at Tukey's test only if you accept the alternative hypothesis and you reject the null. The thing is though, we don't hand calculate Tukey's test. We only get Tukey's test by performing it in SPSS. So let's turn to SPSS to actually get not only our Tukey's test but also our overall omnibus ANOVA f-test. So here are the procedures. You go to Analyze, Compare Means, and then One-Way ANOVA. And take a look at that. Compare means. We're comparing the means of 3 or more groups. Once you've identified our dependent variable, which will go in the dependent list, and our independent variable, which will go in the factor box, we want to click on Post Hoc, and that will open up this big box here, and you'll want to click on Tukey. and then on continue. And then it'll bring you back to your regular ANOVA box. You want to click on Options, and then we want some descriptive statistics because we want to know which groups are more or less than the other groups. Click on Continue, and then finally you can click on OK. And then you'll actually get your SPSS output. So this is your first table. And this first table simply gives us our descriptive statistics. We see our sample size for each group and our total group. We see the mean, standard deviation, minimum, and maximum, and so on and so forth for all of our groups and our entire sample. Our second table, this is going to give us step 3, which is our calculated F-test. And it'll also give us our p-value, which will allow us to complete step 4 of making a decision. So we see that our F-test, same thing we calculated, 12.218. And then if we're going to complete step 4, well, we look at our sig, and what's our rule? Well, here we go. If our p-value is greater than our alpha, we fail to reject the null. But if our p-value is less than our alpha, then we reject the null. In this, we see that our sig is 0.000. In that case, we're going to reject the null, which jives with what we did when we made our decision when we had our hand calculation and we compared our F-test to our critical value. And since we found that we have significant differences, we need to look at Tukey's test to find out where do those significant differences really lie. Before we do that, though, take a look at this. Pay attention to your ANOVA box. Whoa. What happened? Well, if I took out all the other information, are you able to complete step 3 by looking at SPSS? And are you able to make a decision for step 4 by looking at SPSS? No. So what do you have to do then? So given all of this, you can look at both of the tables, Table 1 and Table 2, to really give you the information you need in order for you to calculate your F-test. We see that we have our sum of squares between groups and within groups in our second table. We see our total sample size in our first table, along with the number of groups that we have. So this is another way that you can be tested for ANOVA by doing a hand calculation, even though I'm giving you SPSS output. I'm just not giving you all the information in SPSS to actually just make your decisions. So, since we found significant differences, let's turn to Turkey's test. Not Turkey, Tukey. Oh, she's not a witch or anything. She just served leftover turkey 5 days in a row. Ugh. Alright, so let's take a look at Tukey's test. And we see the top of the table, it's called multiple comparisons. And we see underneath our dependent variable, which is listing here injury severity from 0 to 100, it's telling us that this is Tukey's test. And really what's happening here in Tukey's test is it takes all of our groups, all of our 4 groups, and it compares each one of those groups to each one of the other groups. So essentially what's happening in this multiple comparisons table is that there are multiple t-tests that are happening. But what can happen is that if you just do t-tests over and over and over again without actually doing an ANOVA, you're actually increasing your type 1 error. I encourage you to read the text box that talks about how we increase type 1 error and we inflate our type 1 error if we were just to perform multiple t-tests instead of doing an ANOVA test and Tukey's test. And one thing you want to do though, really here in this table, is since we found in our omnibus F-test that we had significant differences, which is what led us to actually look at this table in the first place, is that once we actually look at this table, what we want to look at is see if there are any significant differences between any two groups. So that means we have to look at our sig column and see if there are any p-values less than or equal to our alpha level. Because if they are, then that means that those two groups significantly differ from each other. And that's where we're seeing the significant differences in the overall F-test. You'll also want to look at the mean differences and also Table 1 for more details in terms of what are the means and standard deviations for those groups and how much do those groups differ. So if we take a look at this table, do you see any groups that significantly differ from each other? Well, we see that Superman significantly differs from all three other costumes: Spider-Man, Hulk, and Ninja Turtles. However, the other three costumes do not significantly differ from each other. Alright, great. Now we know how to obtain our F-test through SPSS, as well as how to make our decision when we have a hand calculation and when we have SPSS output. So head on over to the final video lecture for Chapter 13, where we're going to learn about how we're going to appropriately state our conclusions, and if we have significance, how to calculate and interpret our effect size.